Welcome back. This video I'm just going to do on the chain rule. And what the chain rule basically says is that the derivative of y with respect to x is equal to the derivative of y with respect to x. And what we can do is introduce a third variable, a third function variable, and u. And if we take the derivative of y with respect to u and multiply that by the derivative of u with respect to x, then we get back to dy by dx. Okay. If you think of these dy dx's, they're just very small numbers, but they're still fractions. And so dy by dx, if you think about this, if you cancel out the dy because you got one on the top, one on that, you get back to dy by dx. Okay. And so this is totally fine. And what we need to do, let's get rid of that row so I haven't messed it up. So that's the chain rule right there. And what often happens is if you have a function inside of a function, okay, so what you're looking for when you use the chain rule is a function inside of a function. So if we've got the function e to the power something, but then you've got a tan x here, can you see how there's a function of x inside of e to the x? That is where you might use the chain rule. Or if you have something like log base e of 1 plus x squared. Can you see how 1 plus x squared is a function of x inside of the function log e? Okay, so that's another situation. Sine of tan x. That's the function of tan inside of the function c. Can you see it's not product rule? It's not sine x times tan x. It's actually sine of tan x. There's this function here inside of that function. Here we've got a tan x inside of e to the x. Here we've got 1 plus x inside of log ex. So it's a function inside of a function. So if you can recognize that, then you'll be good. You'll know when to use the chain rule. So let's just have a look at some examples. And just before I move on, when you're looking to find out a substitution of u, it's always the function that's on the inside. So that would be your u. You'd let u be tan x there. Here you've got tan x inside. That's the thing that you want to let u be equal to. It's whatever's on the inside. Here it's the 1 plus x squared that's on the inside. So that's what you'll be putting in there. So whatever's on the inside, that's what you say, let u equal be whatever's on the inside function. Okay. So just keep that in mind when we look at this. Let u be the inside function. Let's do some examples. Okay, an example of this, let's do, start off with y is sine square root of x. Let's just do something like that. Okay, so I've got a function, root x, inside of another function, sine x. Okay, so the first thing to do whenever you get a function inside of a function is to let u be the inside function. What is the inside function? Root x. Now, just so that we can think about what the square root of this, let's make that x to the power half, which is what root x is. Okay, and so to be able to use our, I'll just write it down here to give myself some space. The chain rule is dy by dx. You write that, and then you just add your u's in. So u there and u there. Okay. So what we need is we want to know what the derivative of y is with respect to u, and we want to know what the derivative of u is with respect to x. So let's have a look at this. U is equal to root x to the power half. Therefore, the derivative of u with respect to x, we want to take the derivative of this. What is the derivative of that? The half comes down the front. You write the x, and then that half you subtract 1, so you get negative half. And so that is our derivative there. Fantastic. Now, y is equal to sine root x, and we've let u be equal to that. So therefore, y is equal to sine u. That gives us that the derivative of y with respect to u, we want to know the other part here, that's this thing, is equal to, what's the derivative of sine? It's cos. So the derivative of that is just cos u. Now we can use our chain rule, which is dy by du is equal to cos u times by du dx, which is half x to the negative half, like that. And that's it. Well, not it, but you've used the chain rule. And so now you've got this u still. Now you can just substitute your u back in. What was u? U was the square root of x. So that's equal to cos square root of x times by half, so we'll just put that over 2. And then we've got x to negative half, so that'll be just a root x down here. And so that would be your answer, right, like that. So that is the chain rule. There are shortcuts, and I encourage you to use the shortcut. The shortcut is you just look at the outside function, the inside function. You take the derivative of the outside function, so cos. I'll just get green going here. There's cos there, the derivative of that. You just write the inside as it is, you just leave it like that. And then you times it by the derivative of what the inside was. The derivative of the inside is half x, I think, so that is that down there. So get used to doing the shortcut. If you want to, you can always do it this way, the sort of the slow way, but once you get used to that, once you understand what's going on, it's much faster just to go straight to the answer. I'll do another example or two, see how my time goes. So something like the derivative of, find the derivative of log e 3x cubed plus x. Alright, find the derivative of that. So first thing I would do, just sort of in this situation, I'll just say let, try to change to y, let y be equal to the log e 3x cubed plus x. Just makes our notation a bit easier. And what we want to do now is find dy by dx. Firstly, you want to know, what are we going to let u be equal to? Let u be equal to whatever's on the inside. Okay, so what's on the inside here? We've got 3x cubed plus x, that's on the inside. We're going to use the chain rule, we need to know what du dx is. So the derivative of this with respect to x is 3 comes down the front, so 9x squared, derivative of x is 1. And so there's our du dx, perfect. And so then we've got y equals log e of u, and the derivative of that, therefore the derivative y with respect to u is equal to 1 over u. Okay. This modulus doesn't do anything in this situation because u must be positive anyway, so we get that. So that is fine. Good, we've got that, and all you got to do now is use the chain rule. So therefore dy by dx is equal to dy by dx, and then you chuck your du's in. That's how I remember the chain rule. So dy by du is 1 over u times by du dx, which is 9x squared plus 1. Put your u back in, so that's 9x squared plus 1 over u, and u was 3x squared plus x. And that's your answer. Can that be simplified? You probably take a 3 out of the bottom line. Yeah, I mean, sorry, x out of the bottom line. Doesn't really do a whole lot, but you could do that. But in essence, that's the answer to the question. Okay, good. So the things, and if you think about it in a short way, so I'll get green going. If you just had to take the derivative of this, let me just do it the fast way up here. You look at what is the outside function. Log base e is the outside function. So what's the derivative of log e of anything? It's 1 over. So it'll be 1 over, you leave the inside as it is, and then you multiply it by the derivative of what's on the inside. The derivative of what's on the inside is 9x squared plus 1, and there's your answer there. Okay, so that's the fast way. This is the sure method, the way you won't make any mistakes. This is the quicker method. I'd love you to get used to this. It'll save you lots of time in the exams. Thank you.